Okay, continuing with our trig packet, we're going to get into some of the application problems. So when we first look at this one, it says a surveyor standing 100 yards from the base of a cliff using a machine that can measure angles. She has determined that the line of sight to the top of a cliff is 30 degrees above the horizontal. How high is the cliff? So what we know is that we have our angle, which is right here. We have the adjacent side, and we're looking for the cliff, which is opposite. So we have to go back and think about, well, what uses opposite and adjacent? So that's our tangent is opposite over adjacent. So we have the tangent of 30 degrees equals opposite, which is h, over adjacent, which is 100. So to solve for this, we multiply both sides by 100. So 100 times the tangent of 30 degrees is equal to h. So we just plug that into the calculator. So check my mode, make sure I'm in degrees. So 100 times the tangent of 30 will give me about 57.5, so it's about 57.5 yards. So the height is about 57.5 yards. So the 30-degree angle in the above example, that's called the angle of elevation. Alright, that's a key thing. It's the angle of elevation, because we can also look at something called the angle of depression, which we're going to look at next. So you have two different things. So when we look at it, we have two different parts here. The line of sight and the angle of elevation, and the angle of depression. Now, elevation is going up from the horizontal. Now, depression is going down. But notice the straight line is here, and it's going down. Straight line here, and it's going up. So that's the difference between the angle of elevation and the angle of depression. So when we look at this next example here, so we're given a roller coaster, track is straight, it makes an angle of 45 degrees with the horizontal. So here's your horizontal, 45 degrees. How far do the riders drop vertically while traveling 50 feet? So we want to figure out how far do they actually go down. So here's our angle. We have opposite and we have hypotenuse. So that's going to be the sine is opposite over hypotenuse. So the sine of 45 is opposite, which is our height, over the hypotenuse, which is 50. So now we solve this. So we have 50 times the sine of 45 is the height. You plug that in. So 50 sine 45, and that gives us about 35.35, which is about 35.4 feet. So that's the drop. The drop was about 35.4 feet. If you look at example 3 here, it says that an architect is designing a room that is a home in a town that gets a lot of rainfall. To avoid having too much standing water on the roof must have the 15-degree slope. Assume the distance from the center of the house to the outside wall is 40 feet. Find the length of the roof part labeled x. Here's your angle. That's adjacent, or that's hypotenuse. That's adjacent. So which one uses adjacent hypotenuse? So this is cosine is adjacent over hypotenuse. So the cosine of 15 is adjacent, which is 40, over hypotenuse, which is x. Multiply by the denominator, and then you divide by cosine of 15. So x equals 40 divided by the cosine of 15, which is, so 40 divided by the cosine of 15, about 41.4. 41.4 feet. So that's how long the roof, that part, is labeled x. And if we look at the next one, it says a surveyor standing 200 feet from the base of a tree has found that the angle of elevation to the top of the tree. So notice that that's your angle of elevation right there, horizontal going up. So we need to find this, which is opposite given the adjacent. So the tangent, opposite over adjacent. So the tangent of 15 degrees is opposite over our adjacent, which is 200. So to find x, so we'd multiply by the denominator, equals, we'll call this x, looks like a 0. And then 200 times the tangent of 15 is approximately 53.6 feet. And if you look at number 4, now it doesn't give you a picture, but we can draw the picture. So it says part of a roller coaster track is straight and makes an angle of 60 degrees with the horizontal. How far does the roller coaster drop when it travels 74 feet along this track? So part of a roller coaster track is straight. It makes an angle. So there's our roller coaster. There's a track. It makes an angle 60 degrees with the horizontal. So since this is dropping, it's going to be going down. Actually, I'll draw this picture up here. So it's going to be going down. So that's your 60-degree angle. Because it's dropping, it's going down. How far does a roller coaster drop when it travels 74 feet along the track? Well, this is your roller coaster right here. It's traveling along this path. So that means this path is going to be 74 feet. And we want to know how far does a roller coaster drop when it travels 74 feet long. So how far does it go down? So we want to know, well, what's the actual height here that it's going down? So what's the height that this goes down? So what we are given is 60 is here. We have, here's our right angle. So opposite, hypotenuse. So which one makes up opposite and hypotenuse? Alright, so sine is opposite over hypotenuse. So it's the sine of 60 degrees equals opposite, which is x, over the hypotenuse, which is 74. So we get the sine of 60 equals x over 74. So we get x equals 74 times the sine of 60, which is about 64.1 feet. So that's how far it travels, or that's how far it drops. So if we keep looking at this, alright, number 3, you're designing a house in a town that gets a lot of snow. So what we're looking for is outside wall, angle, adjacent, hypotenuse. So if we have adjacent and hypotenuse, that's cosine, adjacent over hypotenuse. So the cosine of 45 equals 40 over x. So to solve this, you cross multiply. So x times the cosine of 45 equals 40. X equals 40 divided by the cosine of 45. And x is approximately 56.6 feet. When you look at the next one, a certain mountain knows to be 3 miles high. So there's your 3 miles high. From your location, you notice that the angle of elevation to the top of the mountain is 15 degrees. How far away? Well, opposite, adjacent, so we need tangent. So the tangent of 15 degrees equals opposite, which is 3 over x. So x times the tangent of 15 equals 3. X equals 3 divided by the tangent of 15, which is approximately 11.2 miles. After hip surgery, a nurse elevated the patient. We're looking for the height, so 45, opposite, hypotenuse, that's the sine. So the sine of 45 equals the opposite over the hypotenuse. So you get 12 times the sine of 45 equals x, and that's going to give you 8.5. And you would just continue to work on these types of problems. So there's 6, 7, 8, 9, 10. Alright, but what I want to get into real quick is trying to find an unknown angle. So if we look at these, So now if we want to find these angle measurements, so if we look at this first angle, we're given this, which is adjacent, and this, which is hypotenuse. So adjacent and hypotenuse, cosine. So the cosine of our angle is adjacent, which is 10.4, over the hypotenuse, which is 12. So what we have to do to find our angle is we actually take the inverse cosine to the negative first, of this value. So that's when you take the calculator, and here's cosine, but we don't want cosine, we want second cosine, which will give us the inverse of 10.4 divided by 12, and you get about 29.9. So this angle is approximately 29.9. Now, to find the other angle, in red, once again, now we have the hypotenuse, but this is opposite. So to find this angle, its sine is opposite over hypotenuse. So we have the sine of our angle is opposite, which is 10.4 over 12. So once again, we take the inverse sine of 10.4 divided by 12. And so now we do inverse sine 10.4 divided by 12, and it gives us about 60.1. So this angle is approximately 60.1. And if you notice, if you add these two angles together, it's going to give you 90. Because a triangle has to be 180 degrees, so 90 plus 90 is 180 degrees. So that's how we find an unknown angle. So if we look at the next one, an application problem, a 5-foot tall woman casts a shadow that's 18.6 feet long. What's the angle of elevation of the sun? So that's this angle right here. Elevation goes up from the horizontal. So what we have is we have opposite and adjacent. So that's the tangent of our angle. Is opposite is 5. Adjacent is 18.6. So to find this, our angle is going to be the inverse tangent of 5 over 18.6. So you simply do second tan 5 divided by 18.6. Enter, and it gives us about 15.05. 15.05 degrees. In navigation, the direction one is traveling is described by the number of degrees away from north or south. For example, A is labeled north 30 degrees east. So you can see this part's north, and it's going 30 degrees to the east, north to west, and so on and so forth. So that's one way that you can see how this is used in actual real life. So if we look at this, navigator on a ship knows that he is 12 miles south of a lighthouse, and he has a map. So this just shows you an example how far you could get this. To figure this out, well, here's your angle, opposite, adjacent, which is tangent. You plug in your values. Alright, they simplified this first and then took the inverse. Either way is fine. So they showed you how they got that. You can skip that step if you choose to. So if we just do these two problems real quick, we want to find these angles. Look at this one. This is adjacent, hypotenuse, that's cosine. So the cosine of our angle, adjacent is 48.3, hypotenuse is 50. So our angle is the inverse cosine of 48.3 divided by 50, and that is so that's inverse cosine 48.3 divided by 50, and that's approximately 14.98. So 14.98. To get the other angle, you could simply subtract that from 90, or you could set it up as your sine opposite over hypotenuse. Either way is fine. You're going to get the same answer. If you subtract that from 90, you know that should be 75.02. And if we set it up as our equation, opposite is 48.3 over 50. So we need to take, actually this is this angle. So we just do the same thing. So inverse sine of 48.3 divided by 50, and it'll give us 75.0, and then when you look at it, 16.02. Add those two numbers together, it will give you 90. If you notice this one, well, in this case, well, if these are both 7, you should know that these both have to be 45 degrees because they're both the same. It's an isosceles triangle, so they're both the same. But if we want to use this, we can figure this out. Opposite, adjacent, tangent. So the tangent of our angle, 7 over 7. So inverse tangent of 7 over 7 is going to give us 45. So we know that they're both 45 degrees. And we'll just do the next ones. It's just the same concepts of just setting it up. So if you have any questions, we can go over it in class.